Hello students, I hope you all are very well. So today we will discuss about the part 2 of our previous lecture, the origin and evolution of the earth. So I hope part 1 video you have all already watched all the topics that regarding to part 1, and I tried my best. I make the video more interesting by adding a lot of animations, graphics and all to make it more lively. So whatever we have studied there in the part 1 video, most of the topics are based on hypothesis. Hypothesis means what? You already know, a set of assumption. Okay, but a set of assumptions need some specific proof also. So today we will discuss about some important proofs and the evolution, that finally how our earth came into existence. So, myself Pratik Chakraborty, welcome everyone in this beautiful lecture session, the origin and evolution of the earth. Okay, part 2. So, let's begin our chapter. That day, let's recapitulate first few things: that nebular hypothesis we have done, Immanuel Kant and Laplace, mathematician Laplace, nebular hypothesis. After that, Chamberlain concept of cigar-shaped extension. The diagram I have given that in part 1 video. After that, there is a concept of binary theories, Jeffrey and Jeans, Jeffrey and Jeans. So they have given the concept of binary hypothesis and binary theory, that they imagine that there is a one star, and from that one star all the smaller stars emerged, and after cooling and solidification they formed two planet. Next, we have done the concept of Big Bang, and the entire theory of Big Bang we have completed. Today's discussion we will start with the concept of star formation, that how the star formed. But before going to this discussion, few things you should remember: that at the initial stage when these stars are forming, heat, light and rotation, these are the three important parameters that can be considered: heat, light and rotation. Okay, so particularly when these star, okay, when these you can say that this solid material become more solidify, become more denser, gravitational forces started developing. Gravitational forces started developing. The distribution of matter and energy was not even in early universe. These initial density differences gave rise to differences in gravitational forces, and it caused the matter to get drawn together. These formed the basis for the development of galaxies. So that video particularly, what we have seen, that collapsing, all the big matters collapsing each other, and big bang is taking place. So the entire space is full of dust particle. Again molecular divisions is going on, again larger atomic particles started developing, and again collapse takes place. A galaxy contains a large number of stars. So what is a galaxy? You just imagine that a huge gaseous structure of cloud, a structure of cloud in the universe, okay, contains large number of stars. Galaxies spread over vast distance that are measured in thousands of light years. In space, there is no concept of kilometer, centimeter, meter, nothing. There is a concept of light year. The diameter of individual galaxy ranges from 80,000 to 150,000 light years. So what is a light year? Below you can see a box I have added. A light year is a measure of distance and not of time. Okay, we used to measure distance. Light travels at a speed of 300,000 kilometer per second. Considering this, the distance the light will travel in 1 year is taken to be 1 light year. This equals to 9.461 10 to the power 12 kilometer. The mean distance between the sun and the earth is 149,598,000 kilometer. In terms of light years, it is approximately 8.311 minutes. So from here, if I throw a beam of light, suppose I am throwing the beam of light towards Pluto, then how many times it will take to reach Pluto? This is the concept of light year. So in astrophysics, particularly astrophysics and astronomy, particularly in astrophysics, they used to having the concept of light year. So a galaxy starts to form by accumulation of hydrogen gas. The most important gas at the initial stage of the formation of galaxies is the hydrogen, and another gas is the helium. Okay, so hydrogen gas in the form of a very large cloud called nebula. Eventually, growing nebula develops localized clumps of gases. So slowly by slowly, when the nebula started developing, lump of gases also started developing. These clumps continue to grow into even denser gaseous body, giving rise to the formation of star. The formation of star is believed to have taken place some 5 to 6 billion years ago. So what are the things we have understood? First, heat, light, and after that rotation is the initial three important factors. After the development of gravitational forces. Third, getting the atomic particles getting more and more density. Fourth, when all the denser particles coming together and making a lump, it consists of galaxy. And last, the concept of light years. So this is the formation of star particularly. Okay. Next part we will do is the formation of planet. Same process, nothing different. Same. Whatever the concept of star we have seen, the same process. But there is a difference between a star and a planet. Anyone knows what is the difference between star and a planet? If you have any idea, in class 8 you have studied this concept between the star and planet. See, the star are localized lump of gas within a nebula. The gravitational force within the lump leads to the formation of a core to the gas cloud, and a huge rotating disk of gas and dust develop around the gas core. That means what? When the particles getting more and more solidified, they are getting stabilized. That's a fact. They are getting more and more stabilized here. So when they are getting more and more stabilized, they are creating core inside them. Okay, they are creating core. So at the initial stage, what you can see, when the stars are forming, the development of gaseous core is also forming. In the next stage, the gas clouds start getting condensed, and the matter around the core develops into small rounded object. The small rounded objects, by the process of cohesion, develop into what is called planetesimal. Larger bodies start forming by collision, and gravitational attraction causes the material to stick together. Planetesimal are a large number of smaller bodies. So what is a planetesimal? Large number of smaller bodies, and these smaller bodies collide, that is cohesion takes place. Okay, and in the final stage, this large number of small planetesimal accrete to form a fewer large bodies in form of planet. So after a rampant collision, so finally there is a formation of planet. Okay, so that's all about the formation of stars are particularly you can say that smaller than planet. So a many planet that used to what I should say, that used to collide. I mean, sorry, many stars used to collide. Okay, and after a rampant collision, finally we can see a planet. Okay, finally we can see a planet. So if I ask you that what is the basic difference between planet or star, first, planet in orbit spin on their own axis. Spin on their own axis. Okay, well, this is the first important thing between a planet and a star. Okay, planets spin on their own axis, but star doesn't have that kind of fixed position. Stars are incredibly you can say hot, having high temperature. Stars are comparatively high temperature having. On the other hand, planets having relatively low temperature. Stars, they are objects that produce their own light and do not rely on external sources. But planets are incapable of producing their light. Hence, Earth is a planet. With Earth doesn't Earth don't have their his her light. So Earth is fully dependent on Sun. Sun is a star. Earth is a planet. Okay. Stars have a unique effect of twinkling in the sky, but planets do not exhibit this effect. Okay, and finally, the stars change their position. A star change their position in a substantial distance, but a planet very very rarely change their orbit. Okay, many a times it doesn't change their orbit. Okay, very rarely it change their orbit. So that's the basic difference between star and a planet, and we have understood the concept of their formation. Next part we are moving is the basic concept of our solar system. Solar system we have already studied in class 8, 9, 10. How many planets you having, what is the position there, what is the distance there, these are these things. But here we will differentiate two groups of planet. This is the most important thing in class 11. Our solar system consists of 8 planets. You all know, already know this thing. The nebula from which our solar system is supposed to have been formed started its collapse and core formation sometime 5 to 5.6 billion years ago, and the planets were formed about 4.6 billion years ago. So when our solar system consists forming, the initial father star is our sun, our present day sun. So our solar system having 8 planets, 63 moons, millions of smaller bodies like asteroid, comets, and huge quantity of dust grain and gases. Out of 8 planets, Mercury, Venus, Earth, and Mars are called the inner planet, as they lie between the Sun and the belt of asteroid. And other 4 planets are called outer planet. Okay, so after Mars, you can see a very beautiful belt of asteroid, and after that the remaining 4 planets. Alternatively, the first 4 are called terrestrial planet. Okay, the inner planets are also known as terrestrial planet, meaning earth like, as they are made up of rock and metals and have relatively high density. The rest of 4 planets are called Jovian planet or gas giant planet. So if I take you, if I just hold you and just put you in the north pole of Jupiter, and if I just drop you down, so you will not land in Jupiter, you will simply pass out from Jupiter and you will exit in the universe, because Jupiter doesn't have any land surface, it is a gaseous planet. Same goes for Saturn, same goes for Uranus, and same goes for Neptune. Jovian means Jupiter-like. Most of them are much larger than the terrestrial planet and have thick atmosphere, mostly of helium and hydrogen. All the planets were formed in same period, sometime about 4.6 billion years ago. Till recently, 2006, we have done a very great expedition of by the International Astronomical Union. Pluto was also considered as a planet, we all know. However, in a meeting of International Astronomical Union, a decision was taken that Pluto, like other celestial object, uh, re- in recent past may be called as dwarf planet. So it is a partial planet. Hence, Pluto is not a part of our solar system now. Okay, it is known as dwarf planet. So we understand this concept in an animation. In this animation, we will understand this concept. So you can see all the planets in a relative planet side. But if I, in actual planet, in solar system, how they look. See the sun, this kind of big, huge, approximately 109 Earth's diameter. After that, you can see Mercury. It's all comparing with Earth. Okay. After that, we're having Venus. Next, we're having the Earth, the diameter we can see. Next, we're having the Mars. Next, we having the Jupiter. Just compare the size of Earth and Jupiter. Next, we having the Saturn. Next, we having the Uranus. Next, we having Neptune. And finally, we having Pluto, the dwarf planet. So, if I see through a bar diagram, what is the relative position we can see? So just see we can see the bar diagram. So through bar diagram, you can easily understand where is the relatable position of these planets are. Okay, so if I just compress this thing like this way, you can see the actual positions of the planet. Okay, AU means astronomical union. Okay, so this is a video, a very scientific video I have given to you. In Google images, you have already seen the solar system image. So whenever you are going through this video, have a look in the our traditional solar system image. Okay. Next part we are moving is that what is the difference between the terrestrial and Jovian planet? The terrestrial planet were formed in the close vicinity of the parent star, where it was too warm for gases to condense to solid particle. Jovian planets were formed at a quite distant location. So, a true distance, for example, why Earth having thriving life, life forms, different life form, scientists used to say that the position of the earth is very much unique, because earth having neither too hot temperature nor too cold temperature. Okay, point number 2 is that the solar wind was most intense near the sun, so it blew off lots of gas and dust from the terrestrial planet. So Mercury, Venus, you can see. So due to solar wind, so all the atmospheric layer, all the important gases has been just waved off from Mercury and Venus. Okay, the solar winds were not all that intense to cause similar removal of gases from the Jovian planet. So if you want to study the origin of the universe, the four important planets are Jupiter, Saturn, Uranus, Neptune, because they are untouched planet. So as untouched planet means what? Because the energy of sun doesn't interfere their origin. Okay, last important point is that the terrestrial planets are smaller and the lower gravity could not hold the escaping gases. Okay, so terrestrial planets are very much small and the lower gravity could not hold the escaping gases. So there are a lot of gases. We know the transfer of gas in our planet. This topic we will study in chapter 3 of this part. We will understand this point in chapter 3. Okay, so this is the basic difference between terrestrial and Jovian planet. Moving on to the next part, we're having a very beautiful concept of the formation of moon. Okay, so our natural satellite, only one natural satellite we're having, the moon. The moon is the only natural satellite of the earth. Like the origin of the earth, there have been attempts to explain how the moon was formed. In 1838, Sir George Darwin suggested that initially the Earth and Moon formed a single rapidly rotating body. That means you can say that when the Earth is originating, the Moon is there inside Earth. So due to lot of things, the Moon comes out from the Earth. I will show you the animation. The whole mass became a dumbbell shaped body and eventually it broke. The Shigar shaped concept that I've told you, that when a spherical object, a semi-solid spherical object just rotate rampantly like this, it becomes elongated in shape. It was also suggested that the material forming the moon was separated from what we have at present, the depression occupied by the Pacific Ocean. So if you see the image of Pacific Ocean 3D image, you can see easily that there is a huge gap or a crater in Earth near the Pacific Ocean. So many scientists used to believe that from Pacific Ocean or in Pacific Ocean, a comet or a semi-solid object hits, and from there all the materials just sparked out from the Earth. Okay. However, the present scientists do not accept either of the explanation. It is now generally believed that the formation of moon as a satellite of the Earth is an outcome of a giant impact, or what we call the big splat. We will understand this concept of big splat in an animation. A body of the size of 1 to 3 times that of Mars collided into the Earth sometime shortly after the Earth was formed. It blasted a large part of the Earth into space. This portion is blasted material then continued to orbit the Earth and eventually formed into the present Moon about 4.44 billion years ago. So let's understand the concept how the moon formed from this video. So that is the initial Earth you can see. Okay, it's an initial Earth we having. Okay. So what is happening here? A small object hits the Earth. A small object hits the Earth. Hitting position is the Pacific Ocean. Here, present Pacific Ocean. Okay, and the lump is spreading out from the Earth when it hits. See, a lump spreads out, and this lump slowly by slowly started orbiting the Earth, and like this way we having our present day moon. Okay, so like this way used to have our moon. So that's all about the formation of moon. So I hope the concept is clear. The formation of star, the formation of planet, and the formation of moon. Next part we are going to is the evolution of the earth. Finally, we have understood that how our planets and stars formed. Do you know that the planet Earth initially was a barren, rocky, and hot object with a thin atmosphere of hydrogen and helium? This is far from the present day picture of the Earth. Hence, there must have been some event process. So, at the initial stage, it is just a lump of gaseous structure. But if you compare present day Earth, how it has changed, which may have caused this change from rocky, barren, and hot Earth to a beautiful planet with ample amount of water and conducive atmosphere favoring the existence of life. In the following section, we will find out how the period between 4006 million years and the present led to the evolution of life on the surface of the planet. The Earth has a layered structure. From the outermost end of the atmosphere to the center of the Earth, the material that exists is not uniform. The atmospheric matter has the least density, whatever you see in the atmosphere in your top. From the surface to deeper depths, the Earth interior has different zones and different density. So, in present day Earth, we are having three distinctive layers: atmosphere, lithosphere, and hydrosphere. So evolution of atmosphere is hydrosphere is very easy. First question it will come in your mind that hydrogen and helium are the two important gases, but present day Earth having two important gases, that is nitrogen and oxygen. So how they come? We have distinguished it in three stages. The first stage is marked by the loss of primordial atmosphere. In the second stage, the hot interior of the Earth contribute to the formation of atmosphere. And finally, the composition of atmosphere. That means what? When the Earth started solidifying, slowly by slowly, all the harmful gases escape from the primordial atmosphere. Primordial atmosphere means what? Atmosphere having no layer. So a lot of chemical process started taking place at the initial stage, and slowly, unicellular organism formed. And with the formation of unicellular organism, that is particularly plankton type organism, they started contributing oxygen to the atmosphere. The early atmosphere with hydrogen and helium is supposed to have been stripped off as a result of solar wind. This happened not only in case of the Earth but also in other terrestrial planets, which were supposed to have lost their primordial atmosphere through the impact of solar wind. During the cooling of the Earth, gases and water vapor were released from the interior solid Earth. This started the evolution of present atmosphere. The early atmosphere largely contained water vapor, nitrogen, carbon dioxide, methane, and very little free oxygen. The process through which the gases were outpoured from the interior is called degassing. That means taking away of the harmful gases. Continuous volcanic eruption contributes water vapor in the atmosphere. As the earth cooled, the water vapor released started getting condensed. The carbon dioxide in the atmosphere got dissolved in rainwater and the temperature further decreased, causing condensation and rainfall. The rainwater falling into the surface got collected and through which present day oceans formed. So this is a basic evolution that we used to see. So what are the important parameters? First, removal of hydrogen and helium with nitrogen and oxygen. Second, presence of water vapor. Third, impact of solar wind in the primordial atmosphere. Fourth is what? Degassing. That means taking away of harmful gas. Fifth is what? Condensing the water vapor in the atmosphere. And finally, the formation of rainfall and ocean. Like this way, atmosphere and hydrosphere evolved. Okay. So finally, this is the basic concept of origin of the earth. This is a very preliminary stage where we discuss all the theories and scientific concept. Many a times I have pronounced some important scientific concept because geography, I have previously told you, it is not merely a social science. It is furthermore. Okay, you have to incorporate a lot of fundamental science here also. So in your higher studies, you will understand how to prove these things in experimental way, in laboratory way. This is very interesting. So let's conclude this chapter. The earth oceans were formed within 500 million years from the formation of the earth. This tells us that The oceans are as old as 4,000 million years. Sometime around 3,800 million years ago, life began to evolve. However, around 2,500 to 3,000 million years before the present, the process of photosynthesis got evolved. Life was confined to the oceans for a long time. Oceans began to have the contribution of oxygen through the process of photosynthesis. Eventually, oceans were saturated with oxygen, and 2000 million years ago, oxygen began to flood the atmosphere. The last phase in the evolution of the earth relates to the origin and evolution of life. It is undoubtedly clear that initially the earth or even the atmosphere of the earth was not conducive for the development of life. Modern scientists refer to the origin of life as a kind of chemical reaction, which first generated complex organic molecules and assembled them. That means what? A lot of significant changes taken place. Complex organic chemical changes have been taken place, and finally present day life form we used to see. Okay, this kind of record we used to see in fossil, different kinds of rock fossil we can see, microscopic structure, okay, through blue algae, okay, geological formation, dinosaurs, this kind of evolution we can see. Okay, and finally the present day earth we can see here. So that's all about this chapter. So this is a geological time scale. This is not important for your to study. Just for a reference, I have given that what are the important eras and period and how the life evolved. Okay, so you can have a look later on from this video, the geological time scale. So that's all about this lecture. I hope you really enjoyed the concept. So finally, our life, we exist. So we have started our chapter from nebular hypothesis. You remember that from a single atomic blast, where all the singular atoms started developing, the concept of galaxy, dust of cloud, formation of a single planet, and a collision. And this collision give rise to our planet, beautiful planet, evolution, orbiting of planets, and slowly by slowly, after you can say solidification, development of ocean, unicellular life started. After unicellular life, multicellular organism started photosynthesis, and slowly by slowly water animals, and after that dinosaurs started evolving. You have seen the movie Jurassic Park, I think. Dinosaurs and all the important creatures started evolving. So like this way, slowly our planet get evolved. A lot of creatures also evolved with time. A lot of changes taking place in our planet. Continents started dividing, and finally human evolution takes place. From caveman, we are in the present day human. People started understanding the importance of science and art and technology, and finally satellites evolved, and present day humans has been formed. And finally we are in this part to go to moon and to find the relatable evidences. That's all about this chapter. I hope you enjoyed this chapter. Please do revise all the things, and thank you so much. We'll meet in the next class. Take care.